Hello everyone, and welcome back to our lecture for soil science as one of the areas of the board exam for agriculture. And this topic is all about physics as one of the subtopic of the soil science. Okay, as a sort of review, last time we discussed about the soil consistency, by which we define and we understand that soil consistency, we're talking about the behavior or the integrity of the soil structure or the behavior of the soils when subjected to different moisture stress or moisture level. And there are some levels of consistency. We have the harsh consistency, the friable, the plastic consistency, the sticky consistency, and the liquid consistency. And there are other author describe consistency in terms of solid consistency, plastic consistency, and semi-solid consistency, as well as the liquid consistency, depending upon the amount of water and depending upon the forces that binds between particles, either the cohesive or adhesive forces. And we also discuss about the importance of soil consistency, how it affects different soil characteristics and attributes, which eventually affects the crop production. Okay, and today we're going to be continuing with the soil densities. Okay, but before that, again, it is strongly recommended that you must view the previous lectures on soil consistency before diving into this topic today, which is soil densities. Okay, so let's proceed now. Okay, our topic is about soil densities. So let me enlarge this one. So let us first our pen. Okay, so today we'll be talking about soil densities as one of the physical factors of physical attributes of the soils apart from the depth, apart from color, texture, okay, and consistency. So today is soil density. So how will we define densities? Okay, density of an object relates to the ratio of its weight to its volume. So I mean to say, in this particular volume, what is the mass? What is the weight in terms of kilogram or grams of that particular object, be it a soil or even water has a density. So in a model in equation expressed as density is defined as mass per unit volume. And the unit of mass is, it could be kilogram, it could be gram, it could be pounds, depending on the system. And volume could be a cubic centimeter, okay, cubic centimeter, or it could be ml, it could be milliliter, and it could be liters, it could be cubic pound, no, cubic feet, cubic meters, depending on the system of measurement. But in our layman's term, in Bisaya or in Tagalog, pag sinabi nating siksik sa laman, ibig sabihin yan, maliit pero mabigat. So we're talking about density. Gamay pero bugat. We are talking about density because this particular volume, it is gamay, and ang weight niya, which is bugat, that is volume. Pwede rin dagko pero gaan, density din yan. So okay, so mass per unit volume. Given the mass and volume, we can compute density. Then given the density and the mass, we can compute the volume. So depende na lang saan pag-derive sa formula. Okay? So the concept of density, we discuss first the volume and weight parameters of this soil. Okay, so I want to remind you that this particular illustration is highly and very important when it comes to understanding uh, different density related properties of the soil, such as the amount of water, amount of air, and amount of solid. This figure is very important, so please follow with me. Okay. Before I'll go deeper in the understanding of this figure. So let me introduce first the concept of the pore space, or the components of the soil. Okay, the soil composition is composed of if you have a scope of soils, that soil is composed of 45% mineral matter, okay, and 5% organic matter, and 25% air, and 25% water. So yun ang ideal composition ng lupa natin: 45% mineral matter, 5% organic matter, 25% water, and 25% air. But the compositions of water and air, so kung walay tubig, that is 50% air. Kung ang space naman sa yuta is completely filled with water, then zero ang air dyan, then 50% ang water. Okay? So in this particular example, this is just a representation of a soil with different composition, because a soil composed of air, composed of water, solid, which is the mineral matter, and organic matter. OM is organic matter, mineral matter, we're talking about soils which derive from the weathering of rocks and mineral. So the sand, silt, and clay is the organic matter. Sorry. The sand, silt, and clay are the mineral matter. So take note for the correction. Okay, now let's proceed. Okay, the air and water composition of the soil is what we call as pore space. Okay, the air and water is what we call as pore space. Okay, pore space. So sorry for the because I'm just using the mouse, but the spelling is pore space with this spacey, pore space. When we say pore space, we're talking about the portion, or the space, or the portion of the soils which is either occupied by air and water. So therefore, when you think of pore spaces, so that space could be filled up with air and water. That is, when there is no air, it must have contained, for example, it rains, and the water particles are filled up on the pore space. As long as the water will fill up the pore space, all the air will displaced, so that all spaces in the pore space will be completely filled up of water, which is equivalent to 50% of the total composition of the soil. On the other hand, if the soil is completely air dried, or oven dried, or uga, then the water has been replaced from the pore space, so that kung walay tubig, the pore space has been completely filled up with air. So now, it is clear that in a pore space of a soil, when there's rain, when the water completely fills up the pore space, then the air is displaced and zero. Therefore, the relationship between amount of water and air in the pore space is inversely related, so that when there are more water in it, there's less air in it. On the other side, if there are more air in the pore space, there's less water in it. Take note for that. Okay, kung uga kayong yuta, daghag hangin. Kung basa kayong yuta, gamay rag hangin ang pore space, Okay, the pore space in this particular example is expressed as the volume of air. So Therefore, yung yung hangin doon sa pore space must have a volume. Okay? And also, if there's water in it, and of course, the water must have a volume of water. So therefore, the volume of air plus the volume of water constitute the volume of pore space. Okay? The volume of pore space. The volume of pore space now, we're talking about the volume in the soil pore space, or the volume in the soil, or the volume in the soil occupied by air and water. Okay? Take note for that. If the air has a volume, then the air also has a mass. It has a weight. Okay? And if water has a volume, and also water has a mass, mayroon siyang timbang. And in fact, sinabi natin kanina, the ideal soil, the ideal composition of the soil is 25% uh, water, and the ideal volume of air is 25% on ideal water. So take note for that. Okay, because it is needed later on in our understanding in how the formula will be derived, and how the formula will be used in the problem. So take note for that. Okay. On the other side, we have the volume of, or we have the composition of solids in the soil. And in fact, sinabi ko kanina that the solids composed of organic matter and mineral matter, where mineral matter, we're talking about the soils derived from the decompositions of rocks and minerals. These are mineral soils such as sand, silt, and clay, and all different textural classes included therein. In organic matter, we're talking about the soils developed from the withering or decompositions of um, partially decomposed plants and animal residue. So organic matter. And 25% of ideal soil is organic. I'm sorry. 5% organic matter constitute the ideal soils, and also 45% mineral matter in the ideal composition of the soils. If solid has the volume, okay, it also have a weight. Okay, it also has a weight. Now, when the volume of pore space added to the volume of solid, that is now the total volume of the soil. So therefore, the total volume of the soils composed of the volume of a pore space, which is air and water, this one, and the volume of solid, which composed of the volume of organic matter and mineral matter, constitute the volume of solid. So take note for that, because it is needed in our derivation of formula and the problem solving later on. And the total mass on the other side is equals to the mass of the solid, which is the organic matter and mineral matter. So this one. Then the total mass also a constitution of mass of water. So it is this one. So bakit wala na doon si air? Because the volume of air, the weight of air, the mass of air, andito sa baba, ano? Sorry, andito sa baba. So dinagdag lang. But usually, ang mass of air is very negligible. Again, balikan ko. Ang total mass ng total soil should be composed of the mass of solid, which is this one, the mass of solid. So this one, okay. And mass of water, which is this one, plus the mass of air, which is this one. But take note, the mass of air is very negligible, and that's why, or in fact, the mass of water is considered as 0. That's why mawala ito. So the total mass would be mass of solid and mass of water. Okay, again. So please understand this ideal composition of the soils so that we understand how this formula is being formed. Before the formula of the volume of pore space is VE plus VW, and the total volume is volume of pore space and volume of solid. Then the total mass of the soil is the mass of solid, which is organic matter and mineral matter, plus mass of water, being air is considered as very negligible and 0. So take note for that. Okay. So we have another concept. We have the two types of density in the soil. The first one, we have the particle density. So the particle density is the ratio of weight of dry soil. So take note, we're talking about dry soil in here. Because we're talking about dry soil, hindi kasama dito ang volume ng water and air, because air is negligible niya, dry siya, so walang tubig. So hindi kasama dito ang weight ng water because it's dry soil. Again, particle density is the weight of a dry soil or weight of soil solid alone, which is mineral matter and organic matter, to its volume, which is the volume of the solid. So the particle density now is given in this formula. So this is the particle density. Okay. So particle density is the mass of solid alone. So look, going back, we're talking about only the mass of solid, which is this one. Okay. Particle density is the mass of solid alone in this area, is the mass of solid alone divided by the volume of solid alone. Kasi hindi kasama yung volume ng water and air. So take note for that. So ang ina-compute natin dito is ang kabugaton lang sa solid component ng soil, which is mineral matter and organic matter, or sand, silt, and clay, and organic, and relative to its volume. This is now the particle density. But sa binisaya nga pagkasabot, ang particle density ang gibugaton sa yuta nga granulated or bukagay nga yuta o friable nga yuta. Kung na yuta nga hapit na tamnan, kanang medyo granulated na siya, gwapo na yung granules sa spheroidal yung structure or granular or crumb, kunya ang iyahang consistency is friable, so bukagay, dugmok nga yuta, pero dili kayo pino, igo-igo lang gwapo iyahang granule. Ang muna ang density ana gitawag og particle density. Okay, usually the ideal density is an average value is 2.66 gram per cubic centimeter. This is cubic centimeter. So 2.66 gram per cubic centimeter. So kung daghan og mineral ang yuta, gamay ra organic, daghan sa mineral, mas bugat siya, most posible mataas pa ang value ani. Kaya ang definition man sa density is gibugaton sa ingon ani nga gidak-on. So bugat siya unya gamay, taas ang value sa density. Again, bugat siya unya gamay ra iyang volume, taas siya value. So more than 2.66 siguro. Pero kung dako siya og volume nya gamay ang iyahang timbang, so gamay ang ang particle density ana. Okay? So this is ideal. Sa problem solving later on, kung may problem solving related to particle density, so kung it calls for or it needs a particle density unya wala sa given ang particle density, automatic nga gamiton nga constant value. Pero kung given ang particle density sa problem later on, kung naay problem nga magamit ang particle density, kung given, let us use the given particle density. Pero kung walay given, use the 2.66 gram per cubic centimeter. Okay? So again, ang particle density ng sand, given the same volume, mas taas kumpara sa particle density ng clay, given the same volume. Kay mineral man, no? So, alright. So, factors affecting particle density. So, ang factors maka-apekto sa value ng particle density, no? One is organic matter. Kung taas ang organic matter ang yuta, then ang particle density ana baba, gamay ang value. Siguro less than 2.66 gram per cubic centimeter. Pero kung gamay rang organic matter, daghan ang mineral matter, so bugat ang yuta. Okay? So the another factors affecting the particle density value is the mineral composition of the soils. Again, kung daghag mineral ang yuta, usually ang yuta nga gikan sa bato nga nahimong yuta, daghag mineral, so kanang yuta taas og na particle density siguro more than 2.66 gram per cubic centimeter. So, klaro. Okay, as compared to bulk density, so meron tayong particle density, meron tayong bulk density. The bulk density from the word bulk, bulto, no, buo. So, bulto, bulk, buo. So, bulk density, ratio of the weight of solid to its total volume. So, ang tanaw diri is ang weight of solid lang relative to its total volume. Kumpara ganina sa particle density, we're talking about the weight of solid pero relative to the volume of solid alone. This time, total volume kasama na ang volume ng air and water. Okay? So, sa lakad ng istorya, the total volume is the solid spaces in the water, in the soil, as well as pore spaces. Dito sa pore spaces, kasama na ang volume of air and volume of water. So, sa ato pa, ang bulk density is the ratio of the mass of the solid alone, which is the mineral matter and organic matter, divided by sa total volume, in which sa total volume, kasama dito ang volume ng air, volume ng water, as well as the volume ng solid. So, ganun. So, this the another composition is ang bulk density. Kini siya ang density sa yuta nga buo. Dili siya pino, dili bukagay no sa yuta nga kanang bulk. For example, nagkuha kag isa ka bagal, isa ka tibagal or clad, no? Na isa ka clad or bagal na kana nga clad naa siya mass ug na si volume, divide nimo ang iyang mass ug volume ana. Ang iyang density ana is bulk density kay buo man nga yuta, dili siya tong pino, dili itong granulated nga yuta. So take note the difference now, the bulk density and particle density. In which in bulk density, the total volume includes the volume of pore space, volume of solid, which is the mineral matter and organic matter, as well as the volume of pore space, which is the volume of water and air. Now, for ideal or optimal bulk density value, ranges from 1.33 gram per cubic centimeter. So, that's the ideal. Kung mag-umata na kung makaingunta nga gwapo ang density sa yuta, kung ang iyang bulk density ranges from 1.33 gram per cubic centimeter sa bulk density niya, kung imo nang dugmukon, imong pinuhon, ang iyang idea na ang particle density dapat 2.66 gram per cubic centimeter. Ang bulk density nga above sa 1.3 gram per cubic centimeter or mas taas pa sa 1.33, kana nga yuta nagpaila, kana nga yuta gahi o compact. Gahi unang mga yuta ingana, no, kung taas pa siya. Pero kung ang bulk density ng yuta is less than 1.33 gram per cubic centimeter, kanang mga yuta atong matawag humukon, og ang tubig na dali makasulod, ang hangin dali makadagandagan sa ilalom, ug ang gamot dali maka-extend, dali makadagan ang gamot. So maayo kung ang bulk density is 1.33 o at least baba gamay sa 1.33. So nga na siya. So unsa ang mga factors nga maka-affect sa bulk density? The same sa particle. Kung taas ang organic matter, mababa ang particle, ang bulk density mababa. Kung taas ang organic matter, mugaan ang yuta, no? Also mineral composition, kung daghag mineral, mutaas ang bulk density. Nya kung gamay ang mineral composition sa yuta, mababa pod ang density. And also, ang porosity of the soil, kung daghag hangin, daghan og water, also affect the bulk density, because ang bulk density kasama sa pag-compute ang pore space, which is the volume of water and air. Kung ma-change ang volume ng water and volume and air in the pore space, also it affects the value of density. And also the soil depth, no? The soil depth. So sa A horizon, sa upper layer, upper horizon, kung sige og daro, nya butangan og organic matter. So sa A horizon, medyo ang yang density is baba, pero kung magkalawom na ngadto sa B or sa C horizon, ang yang density magkataas, because sa lalom medyo compact gamay, unya labi sa C horizon apay mga bato. Okay, so magdepende. So sa A horizon, baba ang bulk density, labi na organic matter, nya sige cultivate. Sa ilalom medyo taas ang bulk density kay gahi og daghang mineral o daghang bato. Ang cultivation pod, paguna, pagdaro, or any operations of farm also affect the bulk density. And also the soil texture. So given the same volume, taas ang bulk density ng sand kumpara sa clay. For example, isa ka baso nga clay, isa ka baso nga sand, taas og timbang ang usa ka baso nga sand kay bato man siya. Okay? So nga na. Magayon din, taas ang bulk density ng silt kumpara sa clay. So pinakataas nga density is ang sand, followed by silt, then baba ang clay based on soil texture. Okay. So nga na siya. So factors affecting the bulk density. So we have some example in here, no? To compare the particle density and the bulk density. So in the field, we have a 10 cubic centimeter, no? Ang volume ng soil, we have the 10 cubic centimeter of the certain soil appear as, okay, kung solid gid siya, walay water and air, pure solid space and pore space, so kana siya, like we're talking about particle density, kaya wala may solid raman, volume solid raman, dili appeal ang volume of water and air. So we're talking about particle density in here. On the other side, if all the solids were compressed to the bottom, okay, the cube would look like this. Okay, kung i-compress 50% solid and 50% pore space. Itong solid nito, 5% organic matter and 45% mineral matter. For example, if we are to consider the pore space, total volume, and solid volume, we're talking about the bulk density. So, sinabi ko na ito ganina, no? So, for example, in here, in the particle density, so the total volume is 10 cubic centimeter. If, kung i-compress nimo is katunga lade ana is ang pore space, therefore the volume of pore space is katunga sa 10 kay 50% man, so katunga sa 10, so 5%, 5 cubic centimeter katunga sa 10, no? Kay 50% man ang pore space, 50% ng 10, so the volume is 5. Ang volume po ng solid, this one, ang pore space is 5, ang solid is also 5%. Okay? Also 5%. Okay? Ang mass, okay, ang mass ng solid is 13.3 grams. How to solve that? Because if the mass is 13.3 gram, then the particle density is the mass of solid, which is 13.33 gram, divided by the volume of solid, ito, which is 5 cubic centimeter, this one, then the particle density is 2.66 gram per cubic centimeter per particle density. So we're only considering the volume of solid. What about in the bulk density? So the same mass of solid, which is 13.3 grams divided by the total volume. The total volume, which is the BT, this one. Okay. So now the bulk density is 1.33 gram per cubic centimeter. So take note for that because as I recall, and in fact as one of the testimonies of the students that who has taken the exam, so mayroong lumabas sa board exam na ganito. Please familiarize with this. Okay? Okay. So far, that is all about the particle density and bulk density. And I want to go back on this figure again. Please try to understand the figure because it has a connotation and implication on the formulas of a different component of the soil, and even it affects the computation of particle density and bulk density, and how we understand particle density and bulk density. So so I guess uh, we end up only up to the particle and bulk density because we have to continue later on the soil other physical properties on soil and soil porosity. Okay, so that's it. So try to digest all those understanding and internalize on that. Okay, so I guess that's all for today's topic, and please, if you do, please do subscribe and like on this channel. So next meeting, don't feel to attend in our next discussion. That's all for today, and thank you.